Good morning, I am Rashmi Singh, Lodhi, Assistant Professor of Science Engineering Department of SIRT Bhopal. Today's topic of presentation is Relational Algebra. Let us begin with query languages. A query language is a language in which a user instructs the information or retrieve the information from the database. It is basically categorized into two categories: procedural language and non-procedural language. Procedural language: in procedural query language, the user instructs the system to perform a sequence of steps in the database to compute the desired result. For example, relational algebra. Now, we must also be aware of the term non-procedural language. A non-procedural language is a language in which the user describes the desired information without giving a specific procedure for obtaining that information. Example is relational calculus. Although relational algebra and relational calculus both are equivalent formal name, we can say the formal definition of both the algebra and calculus is same, but algebra falls under procedural query language and calculus falls under non-procedural query language. Now our focus is basically on relational algebra. As it is shown, a relation is a mathematical concept based on the idea of set. And set of operations, they together makes a relational algebra. There are basically two types of relational algebras. First is set-oriented operations and second is relation-oriented operation. In the first category, set-oriented operations, there are four basic operations which are shown: union, intersection, set difference, and Cartesian product. These are relation-oriented operations. There are basically five different types of relation-oriented operations. These are select operation, project operation, Cartesian product, join, and division. Now, starting with this, select operation basically selects a subset of tuples from the relational model. Tuples here means the number of rows in the database. Second is the project. It selects all the attributes. Attributes specifies the number of columns. Third is the join. It combines two relations. The difference between select, project and join is selection and projection are basically unary operations. Unary operation means these are implicable only on the single relation, and join operation is compound operation, or we can say it is a binary operation because it involves the use of two relations and it gives a single relation as a result of the operations on both the two relations. Fourth is the rename operation. It renames both the relation as well as the attributes. Fifth is a division operation. It combines two relations in a specific way, consisting of values of one relation that matches all the values in the second relation. So these are the types of relation-oriented operations. Now, proceeding with our example instance, it is an example of database. It consists of both relation R1, S1 and S2. The values are filled here. For example, the boat ID, boat name and the color of the boat. Four data items are filled in the first relation. Similarly, R1, we have created the relation model from this basic database. R1 consists of SID, PID and the date of which the boat has been used. Second is the S1 and third is the S2. Using this relational model, we will use our relational algebraic operations. For example, projection. Starting with the projection operation, it is denoted by pi operator. It is a Greek letter and it is used to items it has to be operated, and relation is a database. This is again an example database. Here the attribute values are student ID, student name, rating, age. The second database, S name and rating are the attributes. By using the selection operator, we have to follow the syntax. Syntax is sigma. Condition is rating must be greater than 8 from the database S2. Now it will evaluate it as shown. It will calculate the value of rating which is greater than 8. So only two tuples from this database has been extracted as a result of sigma. Here 8 is equal to 8, it is not greater than 8, 5 is also less than 8, so these two values are rejected and these two values will be accepted as a selection operator. Similarly, this operation can be performed as a combination of selection plus projection. The output is shown as, we have to use the projection operator, projection S name rating, sigma rating. We use in collaboration of pi as well as sigma, and the output is shown as. We got the two values which are greater than 8. So as a result of pi operator, we get only two columns in the output which are as follows, S name as well as rating. Now next is the union and set difference. These are the simple set-based operations which are used in relational algebra. All these operations must follow two conditions which are as follows. The database must contain the same number of attributes, means the common field should be there. Secondly, they must be of same type, means they must be of union compatibility. For example, this is an example of union. Here S1 is a database, S2 is a database. By performing the union operation S1 union S2, we get the desired output. It takes all the rows. First it checks the compatibility, whether the number of fields of S1 are same as the number of fields of S2. If both the fields are same, the union operation can easily be performed. For example, after performing S1 union S2, we get the desired result, and the result contains number of rows and number of columns similar to the base relations S1 and S2, and it eliminates the duplicate values. Next is the set difference. For example, S1 is a database, S2 is a database. Again, we first check the compatibility, whether the number of columns, number of fields of both the relations are same or not. If these are same, we are able to perform the set difference. S1 minus S2, the result is this. Second is an example of S2 minus S1. Next is the cross product. Cross product is basically denoted by cross operator, and it is represented as S1 cross R1. Each row of S1 database is paired with each row of R1 database. Now the question is, how many rows in the result? So result schema has one field per field of S1 in R1 with field names inherited if possible. So as a result of cross product, we have to use another operator which is known as renaming operator, which is denoted by the symbol row. This, for example, if I am using row operator, then 1 to SID means it says that concatenation of S1 and concatenation of R1. Every field of S1 is concatenated with every field of R1. So we get the cross product of the two databases. For example, S1 and R1. This is showing this example. This is R1, this is S1. By using the R1 S1 cross product, we get these values. Okay. 10.